host and service checks. And that's something that you can look at in your system processes for Nagios. If you see your host check latency or your service check latency continuing to grow larger and larger and larger, it's because you're overtaxing your system. The CPU just can't handle the check schedule it's been given. It can't keep up with it. It's going to fall farther and farther behind. So as a result, you need to look to either modifying your monitoring configuration. You can maybe space out your checks farther apart, reduce the number of checks, or you can look at a distributed option for spreading out the workload. Bottom line for finding the right distributed model for your environment is there isn't a right or wrong way, and there isn't a best way to implement distributed monitoring. It's purely what works best for your environment. It's going to be different for everybody, so you kind of need to weigh the options that are out there and look at your particular setup and say, what's going to work best for us. As you're doing this, you need to think about the logistics of, particularly for the everyday tasks. How am I going to maintain my configuration files? Who's going to handle alerts? Is it going to be on distributed machines? Is it going to be all at a central place? Think about the everyday tasks that are going to happen, because as you continue to scale larger and larger over several servers, like I put in here, a 30-minute task on one server isn't a big deal, but if you have to do it 10 times and you have to do this once a week, that's 5 hours a week. So things kind of add up very, very quickly as you distribute your monitoring environment over multiple machines. So think logistics, think everyday tasks, and create a plan. Every hour of planning that you do is going to save you, tens, 20s, hundreds of hours in actual maintenance time later on. It's costing the company money. So take that into consideration of how you're going to implement it and how you're going to actually maintain it once it's implemented. Something that I've kind of seen too, as your quantity of data increases, getting the useful information out of it becomes a little more challenging, and yet it's something you have to think about as well. For Nagios Core, you can get Nagios Core souped up pretty good. If you've got, say, 30,000 checks running in Nagios Core, that's pretty awesome. But if you look at the services page, you're going to have 30,000 services on one page. So you need to think about how you're going to filter the information, how are you going to effectively view it so you can actually see the information you need to see. Talking with another system admin from Australia, his comment was, I'm not concerned so much with what's working as what's not working. So think about how you're going to keep track of the information and what's important, and how you're going to effectively view it as you continue to scale larger, or even if you just have a multi-site distribution, how am I going to effectively view my monitoring data on 4 different locations? Let's see. So the first model I'm going to cover is kind of I call it the classic distributed model. And this is actually straight out of the Nagios Core documentation. You can find this in the core manual. I kind of redrew the diagram, and of course my image didn't come out straight now, but that's all right. It's basically the idea is that you've got active checks running on external distributed servers. These servers are all initiating checks and processing the results, and then they're actually forwarding them onto a central server. And the central server doesn't do any active checking on its own. All it does is receive results. And the reason this has worked in the past is that this server isn't launching any new processes. All it is processing data as it comes in. The central server just acts as a central viewer primarily, whereas all of these servers are working, doing the actual checking. And like I said, with every single check that's run, as a result is received, the results are forwarded on to the central server. A little bit more in-depth model, and this is, again, straight out of the core manual. The way this actually works is that you've got the distributed servers, and with every single check, you define what's called an OCSP command, which is Obsessive Compulsive Service Processor command. Not a very long-winded acronym, but basically means that every time a check result is received, run this command. And so you can define this. It can be pretty flexible. You can define this command however you want. It can basically be a shell script, it can be a binary, it can be whatever you want it to do every time it receives a result. And so it takes takes the results and does what you want with it. For this particular model, we've got it drawn where it's piped through send NSCA, which is fed to the central server, which receives the result, processes it, and takes it in. And this is even within this classic distributed model, this is one way of doing it. Another way I've heard of people doing it is they basically, if they have a very, very large installation with a lot of checks, they want to keep that central server from getting bogged down. Something that they do is, instead of the obsessive compulsive command, they use an event handler, which basically means every time a state change happens, do something. So if my host goes from okay to down, then take action and do whatever I define in this command. What this does is that every time you have a state change, then the result gets forwarded to the central server. The central server isn't actually monitoring anything, it's just acting as a viewer so you can see everything in its current state. Now your data might be a little bit older, but you'll still get an accurate view of where things are at and what the state of everything is. And this is another way to do it, is with event handlers, where every time a state changes, the result gets forwarded to a central server. With that kind of model, you want to have your notifications on the distributed machines instead of the central machine, just to make sure everybody's getting notified in an accurate amount of time. So, because in the event that, say, you weren't able to get your results forwarded to the central server, that would be problematic for receiving alerts and so forth. One thing to note too, a lot of people don't realize this is a feature with passive checks, is that if you were setting your central server to just receive all results, but you wanted to make sure you're receiving them in a timely manner, you can set what's called freshness checking, and you can set a threshold and say, all right, I'm expecting to receive results every 5 minutes from this machine for this service, and if it exceeds that amount, I want to receive an alert about it, because then something's not working correctly. And I've discussed with a guy where his entire environment was actually just basically cron jobs. And all it was doing was just sending passive results to a central server, and wasn't using any agents or anything like that. Just everything was passive, being forwarded to a central server, and he just had freshness checking enabled to make sure everything was happening in a timely manner. Another thing that's flexible about this model of distributed monitoring is that the child servers can also do local monitoring, and you don't have to necessarily forward those results. So it's pretty flexible, because you can have 4 different locations and say, well, they've got some of their own internal stuff, and this team is going to kind of handle that, but there are some critical things that I want to know at the central server, and I want to see that information. So you can choose what to forward with this particular model. It's very, very flexible. You can define it all the way down to the hosted services individually if you want. I remember talking to Mike Weber, and he knew of an implementation where they were overseeing about 250,000 services, and with that model, they had literally a tree structure for their monitoring environment, where they probably had 10 or so monitoring servers. They had an additional level out here where they had a large batch of servers, and they were forwarding essential hosts and services to this server here, and then this server was continuing to forward central results all to the main server. So the main central server was ultimately overseeing probably about 250,000 services, but alerts and everything like that were handled at these lower level environments. And also this allows for local teams to do their own monitoring. They can add and configure things like that. As I said, distributed servers can receive passive checks, forward them along as needed, so you can have your tree structure as deep as you want. It just kind of depends on your environment, how large it is, how complicated you want to get. But as I said before, plan before implementing anything, because you need to think about as this scales. You got to think about those logistics every single day of maintenance. Strengths of this model: it's pretty well tested, well documented. You're going to find the most documentation on this particular method. It's been around probably the longest, and like I said, it's right out of the core manual. It tells you right how to do it, and so it's pretty straightforward in that regard. And this is also built entirely into the existing Nagios core package. You don't need any external things. If you install Nagios core from source, you can do this basically right out of the box with just configurations and defining your command. So it's very, very flexible. you can define with your obsessive compulsive command or your service or your event handler. You could, if you wanted to, you could offload your performance traffic to another server as well. And this can be combined with some of the other distributed models that we're going to cover in just a moment. Now the challenges with this, and if anybody's running this type of setup, would probably have experienced this firsthand, is how to maintain configs on multiple machines. If you're running the central server, the catch is that you have to have matching configurations on the distributed machines and the central machine. The distributed machines have active checks enabled, whereas on the central machine they're not. And so you have to essentially have mirrored configurations, well, almost mirrored configurations on the central machine. Again, you have to think about a plan as how are we going to keep these synced, how are we going to maintain them, because it doesn't, if you have a large operation, it doesn't make sense to just manually create a config over here, then create a config over here. It helps to have a plan in place as how am I going to effectively keep my configuration synced on all my machines. Some challenges people have talked about that I've heard is that which server issued the check when you're looking at it from the central server. Where did this come from again? I've got 10,000 results and I don't remember what server sent this. Can be a challenge. It's something to think about. The other one is that if your environment gets very large, is that currently where do you process and view performance data? If you're sending everything back, it would probably processed at the central server. So if you have 30,000 results coming in, you have to start thinking about performance data processing for 30,000 checks. Again, it's just a scalability issue, something to think about. You can offload performance data processing to another machine, but it kind of depends on your environment, what you need to do. Some of the workarounds I've heard people talk about. I talked to one guy who used SVN to basically keep his configuration synced. He ran a cron job every single day that went through the configs, and if there's anything new, it just basically ran an update on both machines and kept them synced automatically. So that way all he ever had to do was the local teams on the distributed servers could create their configs and just leave them, and then overnight it would sync up with the central server and they would have monitoring centrally. RSync's another great tool. Utilize cron. Don't do anything manually. You don't have to. Automate as much as you can. Another one is, I think a lot of people that don't realize how powerful templates can be with Nagios. You can create a template that you can create templates and you can piece them together to create a complete config. So I would suggest for your host and service configs, all you have in it is your host name, your host address, and your alias. Everything else should be template. So you can apply a template that says, on your passive server, you can say, passive settings, and and you can just have a setting that is not synced with anything, and you say active checks enabled is 0, and on your distributed server, you can have them enabled. You can apply just a single configuration directive to a host or service through a template. They're extremely powerful. If you haven't read the Nagios core docs on object inheritance, I highly recommend it if you're going to look at this kind of a model, because it can totally save you a ton of time in terms of maintaining the configurations. They don't have to be complicated. Most people with big operations I've talked to, they just have some crazy, efficient, and organized setups with templating. And they make it so that adding hosts and services is very, very easy. All I have to do is just add those couple of directives to say this is a new host, here's his name, here's his address, here's his alias, done. And everything else is handled with templating. And that way, if you need to change something, all you're doing is changing a template, and it affects everything that you need it to affect. So keep your things organized, keep configs organized, and keep them using templates as much as possible. It will save you a ton of time as you maintain training results to a central server. Two popular examples: DNX, distributed Nagios executor, and the author of this is actually here. It's William, I forget his last name, I got it at the end of the presentation. But he's at, what's it? Legend. Okay, so he's actually here.
I'm not the author, I'm one of the contributors.
Oh, you're right there. All right, excellent. so talk to him for details on DNX. I will try and do your software justice as I talk about it briefly. So DNX is a popular example. And Mod Gearman is another one. They essentially work in a similar way in that check results and configs are all managed at the central server, but the actual checking itself is handed off to distributed servers. Here's kind of just a map of it. We've got a central server, everything's viewed here, and then the checks are distributed among worker nodes. And what I think is particularly cool about this is that you can add or remove worker nodes at any time. If a single worker node goes down, the checks will be redistributed to a different worker node. So the only time you're ever in a bad situation is if, of course, the central server goes down, which pretty much doesn't matter what your model is. If the central server goes down for monitoring, you're kind of in trouble. So for Emacs, how it works, when a check is scheduled to execute, job is passed to a worker node. The worker nodes execute the check and send the results directly back to the results queue. It doesn't pipe anything through NSEA. It bypasses that entire step. So it's very, very efficient. And I haven't implemented this myself, but people I've seen, they get a pretty insane number of checks running at a very, very high volume. So if you're in an environment where you need to run 20, 30,000 checks every 5 minutes, this might be a decent option because you can do it with DNX and with this kind of a model. The checks are not associated with any particular worker node. As I said, they can be passed around. If one of them goes down, they can be redistributed. You can add new worker nodes at any time. Strengths of this, essential configuration management. I'm of the mindset of like I only want to do things once, and if I can help it, and this model allows you to do that. And as I said, worker nodes can be added at any time. This makes for solid expansion of your environment. If you are planning on growth in the future, you're able to do that with this model. Now, challenges that I've heard from users is the performance data. Again, if the environment is very, very large, is still typically handled at the central server. And of course, if the master goes down, all checks cease. As I said, that's the case within the monitoring environment. So, I'm sure there are workarounds for this to a degree. I just don't know them off the top of my head. So I figured I'd talk about what you not so much what I know. So. All right. Another one I said is Mod Gearman. It's a similar kind of model. It just redistributes the checks a little bit differently. It's based on you can split up your checks based on like host groups, service groups, and so forth. And it processes events a little bit differently. And then Mike Weber actually, I believe, at some point later this week, he's actually going to give a workshop on installing and setting up Mod Gearman. That's an interest. That's also later this week as well. And so, same kind of model. It's just distributes checks for worker nodes and splits it up, lets you get very, very high volume of checks within a short period of time if you need it. Strengths are very, very similar. Central config management. With this, checks can be split by host groups and service groups. If you've got your network in different locations, that might be handy to have, say, this host group is offsite at this location. If they're running all their checks locally within that network, that might be more efficient and more effective. It kind of depends on the network. It depends on the environment. So, challenges with this, same deal. Performance data is still primarily handled at the central server by default. Again, I've heard of people working around this. I don't know how to do it personally, but I know it can be done. Same deal, if master goes down, all checks stop. And again, a challenge with the cluster model in general, you have to start thinking about as if it grows very, very large, is how do I effectively view large amounts of services on a central machine. This last model is probably something that we're seeing most recently in some of the projects. One of them is is an enterprise product, Nagios Fusion. There's a product called Mensos, and then Check MK Multi-Site is another product that uses this model. It's a central dashboard model. And basically, all it is that you have several independent Nagios instances, and then you basically just have a central dashboard that collects tactical data from each of them, pretty much your summary data from each of them, and you can view it in one central place. It just unifies all servers, ties everything together, and then just at a regular interval, it will pull each server for kind of the summary data, so you can see it all in a central place. Using a diagram for Nagios Fusion, we have this where it has integrated login with Nagios XI, so it doesn't do it with Core as of yet. You still have to use whatever authentication method Core is using, but it works for both Nagios XI and Core. You can fuse all the servers together, and zoom ahead just a minute. Essentially, you get a tactical overview for every single server in one central dashboard. So if you have 20 servers, you can scroll through the list of your different servers and say, hey, I've got 15 problems on the server. You click on it, and it will bring you into that server. This model is nice because it does let you compartmentalize, so that this server, it's got its own set of contacts, its own set of people maintaining configurations. They can do whatever they need to do independently. Same thing on this server, and then just basically somebody at the top can have a high-level overview and see what's going on across all the sites. Now, this is nice because it does compartmentalize all your configurations. You don't have to worry about syncing anything. It does keep it simple. This isn't ideal for everybody, but for some people it is their preferred solution. I've seen this. People who want Fusion a lot of times have the firewall restrictions where they just plain need to have 4 or 5 different servers inside their networks, and they just want Fusion to tie everything together so that all they need to do is click into it and just go see the information in the actual distributed server. As I mentioned, that one thing we have with a commercial product with Fusion and XI is that it's a unified login. So once you're logged into Fusion, you don't have to re-log into XI. You can literally just click in, and it will give you your list of information. Strengths with this is that it is easy to add new servers. You can add as many distributed servers as you want, and then just create a new dashboard in the central server. It's a great high-level overview. With Fusion, there is user-level control of the server views, so if you don't want everybody to see everything, you can have some control over that. You can have a user only see 2 servers while somebody else sees 6 or 7. On the central server, there's little to no CPU usage other than just polling the servers individually, because there's no actual monitoring happening in the central server. With Fusion, it is a commercial solution. It does have support, so there will actually be somebody to help you resolve an issue. I found that to be a bonus sometimes. So depends on how much of a do-it-yourself you are. So challenges is that this by itself isn't a monitoring solution. It's just a central viewer. For Fusion, there's a free 60-day trial, but it does require a license. Not everybody's stoked about a price tag. Again, this is a view of Fusion. Mensos is another one, central dashboard, and this one is a free community project. And same kind of concept. It displays your tactical overview data of all your servers. You can add notes and contact information and so forth. I haven't actually implemented Mensos myself, but it's the same kind of concept, same model. It's just a central viewer for all of your servers. Check MK Multisite is another one, and his software does require. He has kind of his own. Matthias Kettner's developed quite a few Nagios add-ons, Check MK, MK Live, and so forth. And this utilizes most of his suite of products, so this does require some additional setup outside of just the core package. Some people love it. It just depends on your preference. But it's a pretty slick interface, at least from the screenshots and the live demo that I tried. And that is a community-free project. So, not all environments require check distribution. Sometimes you can get by with a single server if you just offload aspects of your environment. So one thing, like if you're using NDO utils as a database backend, and we've documented this for XI as well as just having your database offloaded to another server where it's fetching the data from that can make a big difference. Same thing for your performance data processing. I haven't implemented that myself, but I know people have done it. Daniel Whitberg did it for his installation. He had his own machine where all it did was process performance data. And so just splitting up the different pieces of the monitoring can also be an option, if, depending on your environment and the size. There's some other cool tricks. There are certain files that have continual reading and writing happening to them that are constantly being updated. They use a lot of disk I/O. You can mount some of these files on temporary RAM disks. Now, when if you shut off the machine, these disappear, but These files only exist when Nagios is running anyway. So there's certain files like the status.dat file and the objects.cache file. If you mount these on RAM disks, you'll save a huge amount of disk I/O. You will see a noticeable increase in performance. You can push your server a lot harder. Actually, want to thank Nate Roderick. He gave us the actual, he documented how to do that for us and sent it to us. So that was a cool trick. Let's see. And then Nagios core installs. You know, it totally varies by environment and also what you're checking. If you're running ping checks, these don't take a whole lot of CPU, but if you're doing SNMP monitoring, if you're using like MRDG, things like that, the CPU usage is substantially higher, so you won't be able to scale as large. So depending on what you're checking, some checks take a whole lot more CPU usage. I know that some of the ESX checks are very intensive on CPU usage, so keep that in mind as you're scaling. If you're doing pings, I mean, you could probably push just a single machine up to 10,000 checks without any problem at all. If you're doing stuff that's more CPU intensive as far as what the actual check plugin is, you need to think about that as well. I've done a benchmark with Nagios XI where I did 5,000 checks in 5 minutes. And it ran okay. I didn't do any other really real tweaks to it, but you know, CPU load was running pretty hot at about 5 or 6, which is, I didn't want to push it any harder than that. But whereas Nagios core is there's a lot less overhead, and so you can push that a lot harder. I've seen people running between 10 to 20,000 checks on a single machine with Nagios core. And I'm sure they probably had some tweaks with that, but that's just kind of a ballpark. It totally varies depending on what you want.
There's another tip that you use. You
Yes.
mount the disk. You mount all your disks with a no A time option.
Okay.
You will reduce I/O writing by about 2/3 for Nagios selection. So that's really helpful.
Yeah. And how many of you guys out there are currently using a distributed environment already? For one thing with for us at Nagios Enterprises is that there's only so much we can actually test in a test environment. Honestly, we get a lot of our best ideas for some of the stuff from you guys in the field who actually have to deal with some of these issues. So by all means, be in contact on our support forums or contact us by email, whatever. I mean, we would love to document and help the community with these solutions as much as possible. So if you guys have suggestions, solutions, any kind of solution you documented, we definitely want to be able to push the limits for what both Nagios core and XI can do. The challenge we run into is just purely documentation. Somebody might get it running with 100,000 checks, but they didn't necessarily document it for anybody else to be able to do it again. So any tips and suggestions you come across, we love to hear them. So. Now, future of distributed monitoring. This is always kind of just the whole topic in general. I think is really, really cool of just monitoring environments that continually scale. And I think an important thing that we're going to see in the future is just improved information viewing instead of just raw data. That professor once told me, he said, we have probably more raw data right now in this day and age than we've ever had, but whether or not we actually have any useful information from it more than we've had is still debatable. And I think you get that a little bit as, as you start to get, 5, 10, 20,000 checks, having it viewed as useful information becomes a challenge. And I think something we're going to see in the future is just improvement of actual information, processing this raw data into something useful, something easy to view, easy to understand, easy to identify where problem areas are. Something I'm particularly excited about, I get to help out at times with Nagios Fusion. It's still a pretty young product, and I'm kind of excited about it because essentially we figured out a way where with XI we've got this built in, we can access the APIs, but also I figured out a way with Nagios Core we can essentially fetch whatever data we want from core installs, and so we can, at this point, we can probably aggregate whatever data we want into some sort of central reporting, central viewing from the distributed servers, and kind of just a matter of what people want to see. The only reason we haven't done these yet is because we just haven't had quite enough interest yet to really spend the development time to do it. And so as far as the future distributed monitoring, our best ideas come from you guys, and some of our best features come from people saying, I would really love it if the software did this. And that's a lot of times where our best features and ideas come from. And so we love it when the community jump in and say, hey, it would be really cool if we did this, or it would save me tons of time if I could see this on a daily basis. So, something that I have an interest in, I wrote a project, Nagios BPI, that deals with business process viewing. It lets you define rules for a business process. You can say these two are essential, but say if this group, a DNS cluster of, say, I got 4 DNS servers. If one goes down, it's not the end of the world. We've got backups. I don't need to freak out about it. But if 3 of them go down, I want to receive an alert about it. That's a concept with that. And I think we're going to see more of that with distributed monitoring as well. Just trying to turn that raw data into something useful for information. So the last thing, I want to kind of open it up to you guys, whether it be challenges you've come across or solutions you've come across, or even just features that you guys want to see to make distributed monitoring better and easier. Are there things that you guys have seen that, or that you want to see as far as the future of distributed monitoring? I do want to open it up for questions if people have thoughts or ideas. Yes, sir.
I've got a question, but I think all the solutions that you presented so far have some sort of single point of failure for at least parts of the network. Is there any plans to address that?
As far as kind of talking about like redundancy and high availability options, that is an area too that we're seeing a need for, and we don't have it fully nailed down yet because mirroring your servers exactly. It's easier in Nagios Core with, say, an enterprise solution, Nagios XI, mirroring databases, things like that. It can be done, but it's not a simple process because everybody's environment varies so differently. And so we do, that is an area that we see as a need for improvements, and tweaking is just the high availability. People who need, 2 or 3 mirrored servers, things like that. So that is something that's on our radar for both documentation and future developments.
So, I'm looking to merge it.
As an event broker?
Yeah. Slow down.
I personally haven't messed with it, and I read and I didn't cover that, and I wasn't actually aware that I could do it. I did try to research on the conceptual level of many options that I did, but I actually wasn't aware Merlin had an option to do that as well. If I'm not mistaken, you're the Merlin guy. Yeah. Okay. So there is another option. That's Andreas Eriksson. If you guys don't know who he is, he's on the core development team. He also has another option with Merlin, and I am completely ignorant about it, so I would defer questions to that to you. If people have them. That's cool too.
Educate you over beers,
Right. Actually, do we have the microphone? Jared, can I have you pass around the microphone for other questions? What other questions, thoughts you guys have? Yes, sir. Okay.
So are the main bottlenecks mainly CPU and disk I/O, or are you seeing other bottlenecks in other areas like network latency or stuff like that?
Most of the ones I've heard about from users is the CPU and the disk I/O. Just from previewing Dan Wittenberg's presentation, he said disk I/O is probably the number 1 actually with this, and he mentioned using an actual hardware system instead of VMware, because he said just the difference in I/O from a real hardware server versus a VMware server, he said was just like substantial. So if you really have to push your system hard, it is typically CPU and disk I/O, at least from generally what I've heard from people. Those are the bottlenecks as far as hardware limitations. Go for it.
Well, not so much a question, but I thought I'd mention one solution that's working really well for us combines some of the options you mentioned in terms of using the central dashboard. In our case, we're actually
Can you flip on your mic, actually? Cool.
All right. Anyway, we're using a combo approach with 2 solutions you mentioned. The central dashboard, in our case, Struck, combined with multiple isolated servers that themselves, in our case, use my Peerman.
Okay.
It's a really good solution, at least for us.
Good.
So one challenge that we've had in particular is the temp file concept. When we're processing several thousand requests per second, not requests, results per second on a single server, the temp files and the spooling of that directory is really the issue.
Yeah.
To have some way to direct inject results would be probably best for us.
Yeah, I was briefly introduced as one of the core developers. One thing that we're working on right now is a socket broker API that will basically do something similar to what Guillermo does. It will allow you to inject stuff into a socket straight into Nagios core, and that will be the primary way of doing checks. So we're getting rid of the spool. We're actually not getting rid of the spool files because there are add-ons that dump check results in the spool files. And we want those to continue to work, but they will be implemented as separate processes that just check the spool files and then inject them into the socket. So it will be solved.
Great.
Excellent.
Is there a website or URL that's specific to Nagios Performance tuning?
There is a document in the core documents about performance tweaking for Nagios core. It is core specific. It talks about some of the things that were mentioned here of things like using compiled binaries instead of scripts that have to be pre-compiled. There's things that can be tuned as far as it's called your reverb frequency, whereas your check results come in, you can adjust how often Nagios goes through and processes results. When I ran my benchmark test with Nagios XI, I found that when I was pushing 5,000 checks every 5 minutes, I cranked those frequencies down quite a bit. So instead of like 10 and 15 seconds, it was happening like every 3 seconds, and I was able to probably cut my load down 2 or 3 points just by doing that because it was running more often and it wasn't getting backed up so much. So there are tweaks that can be done just standalone on a single install that affect performance as well. Yes, sir.
Hi, I'm really new to Nagios, so this might be a stupid question. Have you guys thought at all about borrowing from other high availability open source packages like common cache layers or round robining like Memcache or Varnish?
There's ones that we've looked into. We have some of that stuff in development right now. We're trying to get some solutions documented and working. We haven't nailed anything down just as of yet. A solution we do suggest for a lot of people for high availability is like VMware Motion, because it's very simple, straightforward. It does most of the dirty work for us. And that's currently on our to-do list. I'm not the resident expert on it, per se, but that is something that we're seeing as a need for a lot of people. Is they want high availability and they want mirrored servers, so if one goes down, the other one picks up without a moment of loss.
So we're talking about distributed monitoring, but I was wondering a bit more about the distributed kind of configuration of monitoring. So you mentioned it around SDN zone, which is what we're doing and we're using live status, but there's no real elegant solution out there at the moment, particularly if you're using kind of plant maintenance and you've got multiple silos which are secured everywhere, and then kind of keeping all your custom plugins, in sync around different environments. So I'm just wondering if there's anything kind of planned around that side of things, or if you had a really nice solution outside of kind of scripts for SVN, right?
Right. And for core, we don't have a planned solution for like an add-on package that will do that. We have talked about that with XI, that it's just easier to implement some of those things. We did talk about the idea of, in addition to what we have right now with the unconfigured objects, where it pushes the results up to a central server and then asks if you want to add them. Something we want to take that a step further at some point, where it's just the actual syncing of that, where it's like, okay, now if I delete one of those services, I want to make sure it gets deleted on the central server as well. We do eventually want to have that where it's essentially syncing between distributed servers and the central server, and it takes most of that most of that day-to-day legwork out of it, where people don't have to mess with the cron jobs or things like that. So it is on the radar. It's we kind of joke around the office. Most of us on the development side, we have a to-do list that's about 6 months long on any given day. So we do have plans for the future because it does get complicated and it does get time-consuming for people. So we do want to create a solution for that. So that is something we've noticed. We don't have it started yet, but it is definitely on our radar. Something we'd like to do.
Just another quick question on Fusion. Is it SSL? The connectivity for the remote monitors back to the actual Fusion one?
That is a good question, and I don't know actually off the top of my head. I'd have to defer that to Ethan.
Because one of the big things with when you're trying to do this is trying to get by security and how we're going to get our stake information back somewhere. Right?
Yeah, and I do know it uses curl underneath to fetch XML, at least on XI, and also per core as well. So there are options for that. I don't know all the ins and outs of curl, to be straight with you. So I don't. That's as much as I know on that I can answer for you. For that option.
I just wanted to mention that over at Cisco, we've got a fairly robust internal tool for distributed configuration manager for Nagios. Hopefully, if the talks with the lawyers go well, it'll be open sourced pretty soon.
That would be awesome.
You mentioned with Nagios Fusion there's a way that you could limit what users can see as far as hosts. Like how is that done? Is it by host group? Is it by host?
It's by server. In at least on the Fusion level, you can create and add users in Fusion, and you can basically say this user is allowed to see this server, this server, this server. As far as a step down from that. Both XI and Core have user level viewing in terms of if somebody is just defined as a contact, they can only see things that they are a contact for. And so on Fusion, you wouldn't be able to necessarily, I don't know if you'd be able to give somebody a high level overview. It depends on the login that they're used, because when you basically use a unified login between at least Nagios Fusion and Nagios XI, whatever login you use for Fusion, it gets stored in XI. So if you did have, if you entered in, say, a user level account for an XI server as the stored credential on Fusion, on one of the Fusion dashboards, it would fetch data only for that user, I believe. So yeah, it's a good question. I haven't actually had that question before, so I think so, but I haven't tested it myself.
One of the big problems is we do managed hosting, so